Hello, welcome to lesson number 2. In this lesson, we're going to go over the point slope formula for lines. This formula comes straight from the slope equation itself. And if we take this equation right here, the y2 minus y1 over x2 minus x1 is your slope. We can take this denominator of x2 minus x1 and actually multiply both sides by that. Multiply this by the m, multiply it by this side. Over here, it cancels. What you're going to be left with when you do this operation is this right here. We're going to take this equation, we're going to write the y's on the left and the m times x2 minus x1 on the right. So y2 minus y1 equals m times x2 minus x1. Next up, for a equation or for a function, you need a y variable and an x variable. What we're going to do is we're going to replace these 2 points, y2 and x2, or 2 coordinates of a point, with just the variables x and y. And what this is going to give us is y minus y1 equals m times x minus x1. This is our point slope form. And essentially what this equation does is it says if we're given a point and a slope, we can find an equation going through that point with that given slope. We just plug the coordinates of the points in for x1 and y1, plug in the slope for m. Let's try and get some examples with this form instead of the slope intercept form. So again, our slope is m, points x1 and y1 are just the coordinates of any points on the line we're trying to find. So if we're given these 2 points right here, say it points out, what's that, 1, 2, 3, 4, 9, so 4 comma 9. And another point at 6, 6, negative 4. If we want to find the slope between these 2 points, we can just see how far we go up or down. In this case, we go down from 9 to negative 4. That should be 13 units. So my rise is negative 13. My run, so how far to the right or left am I going? I'm going to the right 2 units. To the right 2. So my slope should be negative 13 over 2. If I want an equation in point slope form, all I have to do is say, okay, well, we have y minus y1. I choose a point. I'm going to use this point. So y minus y1. Y minus a y coordinate of a point on the line. So y minus 9 equals m, or my slope, negative 13 over 2, times x minus x1, which is 4. So x minus 4. And this is my equation for the line right here. I could also have used this point and it will give me the same exact answer. I do y minus negative 4 equals negative 13 over 2 times x minus 6. Same line. This right here is subtracting a negative. This will be addition, so let's rewrite that. And that's it. This equation right here will give you the same exact line as this equation right here. That is our line in point slope form. All right. Next up, what about the line between negative 7 and 13 and negative 7 and 1? Let's check this line out. We could graph this and follow the same logic as this right here. However, you don't have to graph this, as your slope follows this formula right here. So instead of counting, what we can actually do is this is our first point. Say this is x1, this is y1, this is x2, this is y2. We can just plug these values straight into the point slope formula and get our slope. So if I do 1 minus 13 divided by negative 7 minus negative 7, what this is going to give us is negative 12 divided by, well, negative 7 minus negative 7 is 0. This is one of those special cases, actually. This is just a vertical line. We could attempt to write this in point slope form, but it wouldn't work out. Vertical lines, it would just be x equals some number. In this case, x equals minus 7. So we don't have a slope, can't write this in slope-intercept form or point slope form. All right. However, if we did have a positive slope, we could just take this negative 12 over whatever number we got, plug it in for m, and then take these 2 points, or these 2 coordinates right here, and plug them in for x1 and y1, or y1 and x1. For problem 2, that's what I'm going to have you guys do on your homework set. So you will find the slope, y-intercept, figure out if the line's increasing, decreasing, constant, or vertical. So in here, this is our slope. We don't have a y-intercept. We won't be increasing or decreasing. We'll just be a vertical line. All right, so slope-intercept form is the most useful. So that's the y equals mx plus b. It has all the information visible, the slope and the y-intercept, and it's also unique. So with point slope form, we actually had 2 different versions of this line, and we could get an infinite number of formulas or equations for the line between these 2 points right here. And any points in the future that would land on that line could also be thrown into this equation and will give us the point slope form. All right, last form, general form. This is never used. Unless you're specifically given this form, you don't have to use it. Sometimes what you will see is this c value moved over to the right, and you'll have ax plus by equals negative c, or maybe they'll even use a different constant and just say it's d. This is standard form. This is really helpful on the SAT, but other than that, it's not really useful. So unless you're given an equation in this form, don't worry about using it. All right, so let's look at graphing slope-intercept by hand. All right, so we're going to be given the slope and y-intercept. We're going to use that to plot the lines ourselves. So in this example right here, we have f of x is 4x minus 3. So in order to graph this line, we know the slope, or the rise over run, is 4. Technically, 4 divided by 1. This will be helpful in graphing in a second. That's why I'm putting this like this. And our y-intercept is negative 3. Excuse me. So what I'm going to do is I'm going to start this out by going on the y-axis. My y-intercept is negative 3. I'm going to go down here to negative 3. And this point should be on my line. So negative 3 on the y-axis. Now what my slope tells me is it's my rise over my run. So how far I'm going up and how far I'm going to the right or left. I guess up and down and right and left. Both of these are positive, so I'll go up 4. So 1, 2, 3, 4, here to 1. And I'll go to the right 1 unit. So my next point will be right here. Now 1, 1. And then I can go up 4 units again to 5 over 1 to 2. Next point will be right here. If you want to go to the left, again, this slope of 4 over 1 can also be read as negative 4 over negative 1. Again, 2 negatives, when they're divided, do give you a positive. It's the same thing as 4 over 1. If I go down 4 units into the left 1 unit, this will also give me another points on the graph. Then there will be a line connecting these points all together. That will be my line. Next up, if we want to graph g of x equals 4x minus 2, so instead of minus 3, we have 4x minus 2 slope, I'm going to use the same trick. going to put it over 1. That way we have a number there to represent our run, how far we're going left and right. Start out at -2 now. We'll go up 4 units over 1, up 4 units over 1. We can also go down 4 units to the left 1. That'd be... Oh, I guess this line is a little bit crooked. However, these lines, as you may notice, ignoring the horrible drawing, will end up being parallel, as they will never touch each other. Or I guess they should never touch each other if your handwriting's decent. All right, so that's line A. Let's look at line B, or line h of x now. So this one is -4x plus 9. Using the same trick, put it over a 1. Our y-intercept is 9. So we go to 9 on the y-axis. Now, instead of going up 4 and to the right 1, my rise is -4, so I'll go down 1, 2, 3, 4 units. And my run is still +1, so to the right 1 will be right here. All right. Next up, we'll go down 4 again, so 5 down to 1, and then to the right 1 again. We can keep on continuing that pattern. This line will connect through all of those points. If you wanted to go to the left, instead of -4 over 1, you could read this as 4 over -1. And again, both of these are a slope of -4. You go up 4 and to the left 1, you would get a point over here. A little bit of algebra review. All right, next up, this is actually the same exact line as the original line, so it would just be this right here. Now L of x. This is -1 over 4x plus 5. So again, don't be intimidated by the fractions. We actually have fractions here already. So -1 over 4x plus 5. Let's go up to 5 on the y-intercept. So y-intercept 5. Now my slope is -1 over 4. So this can be read as -1 over 4 or 1 over -4. Both of these give you the same value of -0.25 when you evaluate them. It's just they're written differently. So let's look at -1 over 4 if that's my rise and my run. So let's say my rise is -1. So instead of going up 1, I'll go down 1. My run is +4, so I'll go to the right 4. If I look at this and keep going, down 1 to the right 4, or right here. What if we read the slope this way though? What if it was 1 over -4? Then instead of going down 1 and to the right 4, and my slope or my run is positive, or rise is positive, so up 1. My run is negative, so I go to the left 4. And these points are still on the same line. So probably should have used different colors for each one of these lines. However, this is my final line. All right. What we actually have right here is a case of parallel lines and perpendicular lines. So parallel lines are lines with the same slope but different y-intercepts. That's the first two lines we went over, these two right here. They are parallel. Right, so these lines will never cross path or never touch. However, perpendicular lines are lines that intersect at a 90-degree angle. And when you're looking at these slopes, they will have a negative reciprocal or reciprocal slope. So if this line has a slope of 4 over 1, if we take the 4 and 1 and flip them, so we have a slope of 1 over 4, and then change the sign, so instead of positive, it's negative, we end up with something like this right here, the slope of line D. These are perpendicular lines. They will intersect at right angles. So line D will intersect with lines A and the original equation at 90-degree angles. That's this right here, this right here. Again, all of these will be 90 degrees. You can sort of make a square all the way around if you want to. However, the drawing is getting a little bit cramped. If you multiply two perpendicular slopes together, you should get -1 every time, no matter what the initial value is. So if my original slope is 5, I want a perpendicular slope. We do -1/5. So again, instead of 5/1, it's now -1/5. And the y-intercept doesn't really matter. That will just bring the line down or up depending on what it is. Or these two slopes, when I multiply them, will give me -1. Let's look at this final part. So right here, give the equation of a line perpendicular to L of x equals -3x minus 1 and passing through 2, 4. What about a line parallel to L of x passing through that same point? So let's look at this. We have the equation L of x equals -3x minus 1. Our slope right here is -3. This is going to be the key to finding these equations. If I want a line perpendicular to that, well, what I'm going to have to do is I'm going to have to, first of all, this isn't written as a fraction. I'm going to write it as a fraction. Anytime you have a whole number as your slope, you can always put it over 1. That's what I've been doing up here. Then I guess we did it for all of these. We didn't do it in this one previously because we already had a fraction. So -3/1 is my slope. So I want the negative reciprocal. So instead of 3/1, it's going to be 1/3. And this is for my slope. So m should equal this. And also, instead of a negative, I want positive. You don't have to write positive, as any number without a sign is implied to be positive. So if I want a line perpendicular to this right here, its slope has to be 1/3. Now we also know that we have to pass through this points. Well, this is what the point slope form is for. We know the slope has to be this, and we know we have to go through this points. Let's just write it out straight according to the formula. Y minus y1 equals m times x minus x1. Y minus y1, so again, this will be x1, this will be y1. Y minus 4 equals m, or 1/3, times x minus x1, or x minus 2. And this will be my line. Again, if we graph these, which we will in just a second, they will be perpendicular. Now let's look for parallel. Parallel lines have to have the same slope, but different y-intercepts. If they have the same y-intercept, they will end up being the same exact line. So let's look at this. Well, we know our original slope is -3/1. So if we want a parallel line, the slope has to be the same, -3/1. Our original y-intercept is -1. So putting this in slope-intercept form may be a little bit trickier. However, let's give it a shot. So parallel to L of x and goes through this point. So I'll do y minus 4 equals -3/1 times x minus 2. All right. This will be a line that is parallel or has the same slope, but we have to check if our y-intercept is the same in this equation. If not, we have to use a different points because this point would just give us the original equation. So in order to check that, all you have to do is plug in 0 for x. And see what that gives you. So if we do that, so again, this is our equation. Right here, we'll just check. So y minus 4 equals -3/1 x minus 2. Or sorry, now we're plugging in 0 for x, so 0 minus 2. And we just want to see if this gives us the same y-intercept. If it doesn't, we're good. These are parallel lines, they are different. If it does, then there's no way to solve this problem, as this original line is going through this point. So now to solve this, I'm just going to solve for y using regular algebra. So 0 minus 2 is -2. -3 times -2, that'll just give me a +6. So this right-hand side evaluates out to just be +6. Now I'm going to add 4 to get y by itself. All right, so my y-intercept should be 10 in this equation, which is different from -1, so we are good. This equation works. Now let's look at Desmos. So if we go to Desmos, get this in here. This is from a previous video. Let us plot these equations. So y equals -3x minus 1. And then we're going to plot y minus 4 equals 1/3 times x minus 2. All right. Then we've got two lines that are perfectly parallel. And this second line, if we plot the points 2, 4, goes right through that point. So that's the perpendicular line. Now let's check the parallel line. Y minus 4 equals -3/1 times x minus 2. It's actually a little bit of a shortcut here. All right, so this line goes through the point, and it's parallel to the original point, our original line. So we are good on both of those. This homework number 3 or problem number 3 will be part of your homework, so I won't do those this time.